Hello and welcome to another Ginger Mathematician video where I'm going to do a walkthrough, but this time for the iGCSE 0580 course, which is the same as the 0980 course. It's just graded differently from 1 to 9 rather than A star to G. And we're going to take a very up-to-date paper here, so May-June 2021. This is 1 hour 30 minutes long, it's 70 marks, and a calculator can be used as we go through. Right, let's get started. So question 1, we want to write down the order of rotational symmetry of the diagram. So this phrase rotational symmetry is important. What this means is how many times I can turn the shape and it looks the same. Now notice we have a square here. So this is 4 here. And if we turn the shape, so try and visualize this in your mind, we can see we can actually turn it once, twice, 3 times, and then 4 times back to its original shape. So our order of rotational symmetry, if we can turn the shape, how many times does it look the same? Well, we've got once, twice, 3 times, 4 times. So our answer is going to be 4. If you find that concept confusing, then please do check out the video above where I go through rotational and line symmetry as well. Question 1b, we are going to draw all the lines of symmetry. So the key ones are we can go downwards here. Notice a line of symmetry splits the shape into 2 equal shapes. We can also do this horizontally as well. Now in the exam, please do use a ruler. But notice we can also go diagonally as well. So don't forget the diagonals do work for a square. They don't work for a rectangle, but they do work for a square. So again, try and make the lines as straight as possible. A ruler is highly advised. Otherwise you get wonky lines like I've done there on the board. So you can see you get 2 marks. So 2 marks for the horizontal and vertical, and then 1 mark for the diagonal as well. So question 2, the probability that a train is late is 0.15. Write down the probability that the train is not late. Now remember, all probabilities, let me write this down, all probabilities add up to 1. Yeah, to cover all the situations. So this is worth writing down. All probabilities add to 1. And a train can either be late or not late. That covers all the situations. So we need to work out what do we add to 0.15 to get to 1. Well, let's think about this. Well, if we do 1 minus 0.15, we can then work out the probability the train is not late. So 1 minus 0.15, now you can use your calculator for this on this exam as well. So this is going to be 0.85. So the key thing to realize here is train is late, train is not late. Those have to add up to 1. What do we add to 0.15 to get to 1? Well, that's going to be 0.85. Okay, let's move on. So question 3, and this is something, if you look to my prediction video, it's been coming up far more often, these stem and leaf diagrams. So make sure you have revised this before the exam. Now we've got 16 students here. That could be useful later on. And we've got this diagram here. Now the key is very, very helpful. It helps us realize what the information means. So for example, 1, 2 means 12. 1, 5 means 15. 1, 6 means 16. If we take down here, 3, 2 means 32. 3, 3 means 33. 3, 4 means 34. So there's another way of actually displaying data. Now I'm going to start with B and C first, before then I look at the median. Now the mode, remember, is the most common number. Okay, so it's the most common. Now if you look at this, you probably think, well 1 is the most common here, but the answer is not 1. Notice these 2 numbers do not represent 1. We have to look at our key here. They represent 21. So our mode is going to be 21 hours. These 2 are the same. They're both 21, and we have 2 of them, which is 1 more than any other number that we actually have here. The range, remember, this is something you do need to know for your 1 mark, is the highest number minus the lowest number. So highest minus lowest. Well, what's our highest number here? Well, that is 47. So let's write that down. And then what's our lowest number? Well, that's 12. And we do 47 minus 12. And if we work that out, we'll get the answer of 35. I'd say 34. It's not 34, it's 35. Again, this is a calculator paper. Use your calculator, check these things in the exam. Now the median, we can do this a couple of different ways. I'm going to do it the sort of most straightforward way I would find, and that is we cross out the bottom number, we cross out the top number, and we keep doing that process until we get either one number or we get two numbers in the middle. And actually we're going to get two numbers in the middle, as you'll see shortly. So we cross out 12, we cross out 47, we cross out 15, we cross out 45, and we continue this process. Now just make sure you're not rushing. So here, 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 here. And notice we do get this situation with two numbers. Now notice the two numbers we have here are 27 and 29. And we want to find the median, so the number in the middle. So we want to find halfway between these two numbers, and halfway between 27 and 29 is equal to 28. And that's our answer for 1 mark. Okay, so make sure you revise this topic. This is coming up more and more often on this course. Number 4, we've got some angle calculations to do here. So we've got two parallel lines, that's very important. We can use all that knowledge you've built up of corresponding alternate interior angles, and we need to find the values of A, B, and C. Very typical 0580 question. So let's start with angle A. Now notice this angle here, 59, is vertically opposite A. So we know then that this angle is the same as this angle. Okay, this property, I'm going to write down the answer, 59 degrees. And the reason for this, I'm going to put this in brackets, this is not needed, is vertically opposite. So if you're going back to revise and going through this particular video, then the reason that's 59 is because it's vertically opposite the 59. Okay, so now we need to work out B and C, and at first glance this is not so straightforward. However, we do have a corresponding angle. So if I take this angle here, this angle, the whole thing, is the same as this angle over here. Okay, so if I draw this in, this is what we call an F angle. Okay, so notice I'm going to get an upside down F. And these are the things to look for when you're working with angles in parallel lines. Now that angle up the top there, we need to do 59 plus 37. So you can do this mentally, of course, or you can use normal addition. So 6 carried a 1, 5 plus 3 is 8, plus 1 is 9. So this whole angle here is 96 degrees. Let me write that over here. And that means that this angle here must also be 96 degrees, because this is an F angle, it's a corresponding angle. From there, then we can use our normal angle facts. So we know angles on a straight line must add up to 180. So to work out C, we do 180 minus 96. Now we can do that mentally, we can use the method I did above here, or your calculator of course, and we're going to get the answer of 84. So I'm going to write that in here. And this was 59 from what we talked about before. And remember, we know that angles in a triangle add up to 180. So if we add together 84 and 59, notice I'm showing you different methods of the basic calculations. That's on purpose here, just to show you what we can do. So 8 plus 5 is equal to 13, plus the 1 is 143. And then to work out this angle, we then do 180 minus 143, and that's going to give us the answer. I'm going to do this one mentally. That's going to give us the answer of 37. So B, so you need to know which angle is which. This is 37, so let's write that down, 37 degrees. And this angle here, which we worked out earlier, was 84 degrees, like so. Again, please check your answers so you can go through exactly what I've just done here. So feel free to rewind the video and have a look and ensure that you understand how we got all our answers. Now notice this paper is out of 70 marks and we've already got 1, 3, 4, 5, 6, 7, 10 marks out of 70. So we've already achieved the full marks on 1/7 of the paper, which is pretty good going. Okay, and let's carry on. So we've got some vector work to go through. So we need to work out the addition and multiplication of some vectors. So with vectors, do not overcomplicate this. So the key thing to remember here is we just add the top together and we add the bottom together. So the x component and the y components. So we do 8 plus 6, which is equal to 14. And carefully negative numbers here. So -5 plus -1. A plus and a minus makes a minus. -5 minus 1 is -6. Okay, so we pop that in there. So it's -5 degrees outside, it gets 1 degree colder, then it's going to be -6 degrees. Think of it in terms of temperature. And the second question, when we're multiplying by a scalar, by a number in front of our vector, we just multiply each of these numbers by 3. So -4 times 3 is equal to -12. 3 times 7 is equal to 21. Again, always check on your calculator if you're not sure. Okay, just like that. Right, on to some sequences. So the nth term of a sequence is n squared plus 3n. So we've got a lovely quadratic. And we need to find the first 3 terms of the sequence. So the way I'd approach this is I'd write down u1 for the first term of the sequence. And wherever I see an n, I'm going to put a 1. So I go 1 squared plus 3 lots of 1. And let's just think this through. So 1 squared is equal to 1. 3 times 1 is equal to 3. And 1 plus 3 is equal to 4. And I'll be very systematic about doing this. So the next term of the sequence, we're going to find the second term of the sequence. So wherever I see an n, I'm going to put a 2. So we get 2 squared plus 3 lots of 2. Again, let's just be very careful as we go through. 2 squared is equal to 4. 3 times 2 is equal to 6. So I do my squaring and timesing first. Then I add them together, giving me 10. And then let's do u3 as well. So wherever I see an n, I'm going to put a 3. So 3 squared plus 3 lots of 3. I'm going to put 2 brackets this time, why not? So 3 squared, be very careful here. 3 squared is 3 times 3, which is equal to 9. 3 times 3 is equal to 6. No, it's not equal to 6, equal to 9 as well. Think about what I literally just said. And then 9 plus 9 is equal to 18. So we put 4, 10, and 18, like so. So when you're generating a sequence, just replace the ends with a 1, replace the ends with a 2, replace the ends with a 3, and then you'll generate your sequence. Now we have a different sequence now. So that question is done. This is not linked to what we've just done. And we want to find the nth term of the sequence. So the way I generally teach this is we look for our difference. So notice we're going down 7 here. 25 minus 7 gives me 18. And 18 minus 7 again gives me 11. 11 minus 7. So we're going down in 7s, which is a good starting point for our nth term. And if I want to work out my nth term, I use this notation um. We use it as A level and IB. Again, but you don't have to worry about that. The key thing is the next part. So we're going down in 7s, so we write minus 7n. And then I look at the number I've just written, so that minus 7. So let me underline this. What do I do to minus 7 to get to this first number in the sequence 25? So what I'm thinking in my head here is minus 7 plus what is equal to 25? That's the question that's going through my head. And hopefully you can see at home that the number must be 32. Again, check on your calculator. This is why we have our calculator there. So minus 7 plus 32 gives me that first term 25. So I need to add that onto my nth term. So the final answer is minus 7n plus 32. You could reverse this around. It looks a little bit better algebraically, but both answers are acceptable. So key thing, find the common difference for a linear sequence. What do you do to the minus 7 to get to the first number 25? Well, I need to add on 32. Okay, and we have a simultaneous equation, classic iGCSE question. So the key thing, whenever we get simultaneous equations at iGCSE, is this is our strategy. So I'm going to put strat for strategy, is we need to make the x's or the y's the same number. So 2y, both 4x, etc. So we look at this and we go, well, probably the easiest way of doing this is if I times the whole bottom equation by 2, because if you multiply by both sides, it doesn't change anything, then my x's will be the same, which is very helpful for my next step. So I'm going to copy out the first equation, 2x plus y is equal to 3, and I'm going to multiply everything in this equation by 2. So 2 times x is 2x, that's what we wanted. Minus 5y times 2 is minus 10y. And 40 times 2 is equal to 80. Okay, so now I've achieved my step 1, which is making the x's, in this case, the same. Now my second step is to use what we call elimination. So I'm going to take the bottom equation away from the top equation. Seems kind of weird, but keep with it. You'll see where we go from there. So 2x minus 2x disappears, 0, that's good. Y minus 10y, 2 minuses make a plus, y plus 10y is 11y. Again, you can do this on a calculator here. 3 minus 80 is equal to minus 77. Notice we're doing 3 minus 80, not 80 minus 3. At this point, well, we want to get the y on its own. So what's the opposite of timesing by 11? We want to divide by 11 on both sides. And if we do that, we're going to get y is equal to minus 7. Okay. Now we've got minus 7 here. So we haven't finished the question yet. We've only got one of the answers. So we need to work out what x is. So I'm going to substitute the y back in that very first equation there. So I'm going to substitute, change, y into equation 1. Now what do I mean by that? Well, I'm going to copy out this equation, and wherever I see a y, I'm going to put a minus 7. So 2x stays the same, plus y, I'm going to change that to a minus 7, and that's equal to 3. At this point, this is a standard equation to solve. We want to get the x on its own. What's the opposite of minus 7? Well, plus 7 on both sides. This cancels with this. I'm left with 2x. 3 plus 7 is equal to 10. Okay, what's the opposite of timesing by 2? Well, I want to divide by 2 on both sides. This cancels. That's cool. I get x. And then 10 divided by 2 is equal to 5. So we get our final answers of x is equal to 5, and y, don't forget, is equal to minus 7, like so. Again, please do check your answers, so check what I've done and make sure it makes sense to you. Okay, and on to question 8. We're getting through this paper. If you're liking the content, then do think about liking and subscribing. It goes a long way to supporting the channel and makes me happy. So I'm sure that's a good reason to subscribe. Right, question 8. So without using a calculator, so we need to show our working to get our 3 marks, we need to work out 1 3/8 minus 5/6. So step 1, I'm going to change the 1 3/8 to an improper fraction. So 1 times 8 is equal to 8. 8 plus 3 is equal to 11. So I can rewrite the first fraction as 11 over 8 minus 5 over 6. So that's our first step. Write it as an improper fraction. Step 2, we need to find a common denominator. Now we could times them together and do 8 times 6 is 48, but there is a lower common multiple, which is 24 instead. Notice 8 times 3 is 24, 6 times 4 is 24. So 24 also works, and will keep the mathematics, the arithmetic, a little bit easier. So we want to change each of these fractions into out of 24. Well, what do we multiply 8 by to get 24? We times by 3, so we have to do the same to the top. So 11 times 3 is equal to 33. What do we do to 6 here to get to 24? Well, we're going to multiply by 4. So then we do 5 times 4 is equal to 20. And once we have the fractions the same, so both out of 24, we can simply just minus the numerator and leave the denominator alone. So if we minus these fractions, 33 minus 20 is equal to 13. And that's our answer, 13 over 24. By taking 24 as our denominator and not 48, we avoid having to do some simplification at the end. So it makes our life a little bit easier. Just to recap, we change this to an improper fraction, 1 3/8 to 11/8. We find the lowest common multiple or lowest common denominator, which is 24, and then we change the numerators accordingly and then get our answer. Very nice. This also always comes up, by the way, on the 0580 paper. It's literally my #1 topic when it comes to my predictions. Question 9, so we've got some coordinate geometry to do here. So A is the point 5 minus 5 and B is the point 93, and we want to find the midpoint of AB, so halfway. Now there is a formula you can use to do this, but I tend to do it slightly differently. So I want to find the midpoint, so I'm going to use M for midpoint. And what I do here is I look at my x coordinates, 5 and 9, and if I draw this like on a scale, I want to know what halfway in between is. Now you can do 9 plus 5 divided by 2, but I think many of you out there will notice that 7 is halfway between those numbers. So the midpoint will have 7 as the x coordinate, and then now we look at the y coordinate, minus 5 and 3, and do a similar analysis. So here's my 5, here's my 3, and I want to work out halfway in between. Okay, and I think many of you out there will see if we add those together and divide by 2, our midpoint in between is going to be minus 1. There's a 4 gap in between here, and there's a 4 gap in between here. So we get our answer of 7 minus 1, which we can pop in here. And now this is a very typical question. They want you to find the length of AB. So just to give you an idea of what's going on here, I'm going to draw a quick sketch. Again, it's not to scale, but it's just to give you an idea of what's going on. So our coordinate A is 5 minus 5. So to get 5 minus 5, we go 5 along and 5 down. So A is going to be roughly here. And then our point B is going to be 9, 3. So it's much further along, but a little bit up. So let's just call this B. And what the question wants us to do here is find the length of this. And the way we do that is by using a bit of Pythagoras. So essentially what we need to do here is if I draw in a right angle triangle, I just need to use Pythagoras where I need to know these lengths. Now if I pop in 9, 3, and here it's going to be 5 minus 5, this will help give us some context of working out these lengths. So if I change my pen color to green, let's start with this length here. Well, my y coordinate is equal to 3. My y coordinate here is minus 5. What's the distance between minus 5 and 3? Well, that's going to be 8. Okay, so if you count along from minus 5 upwards to 3, that's going to be 8. If I do the same process here, I'm going to get, well, the difference between 5 and 9 is equal to 4. And at this point, I can use Pythagoras. And if you've forgotten what Pythagoras is, well, it's that formula you've probably seen before. A squared plus b squared is equal to c squared. And we're going to use that formula pretending that this is c here. So let's work through this. So c squared is equal to a squared. We'll call this 4 squared. And this is going to be 8 squared. So we do plus 8 squared. And let's just work these things out. So if we do 4 squared, that's 16. If we do 8 squared, that's equal to 64. And if we add those together, 64 plus 16, that's going to be equal to 80. But remember what we've worked out here is c squared, and we want to work out c on its own. So what do we do to both sides here? What's the opposite of squaring? We want to square root on both sides. And if we do that, we're going to do the square root of 80. At this point, I open up my calculator and then see what the answer is going to be. Okay, and you can see here that my answer is 8.94 to 3 significant figures. So I'm going to pop that back in. And I write that in as my answer. So we have 8.94. I'm going to tell the examiner I've rounded to 3 significant figures like so. All good. Question 10, that's going to be quite hard to do on the computer because I would use tracing paper, but I'll do my best to go through question 10a. So this is a very typical kind of question for transformations. They want you to describe how to go from one shape to another. So we're going to start going from shape A to shape B. And they want 3 bits of information because we've got 3 marks. So if we look at the shapes here, we can see there's a rotation going on. The shape has been turned. So for 1 mark, we need to pop in rotation, like so. Then we need to think how it's been turned. Well, there's been a quarter turn here, so that's equal to 90 degrees. Now we need to decide which way are we turning. Are we going clockwise or anti-clockwise? And you can see we're going against the clock. We're going round to the right, so that's going to be anti-clockwise. Or counterclockwise is fine. So those two bring us the second mark together, 90 degrees anti-clockwise. But you also need to know where to rotate from as well. And this is where tracing paper comes in. So let me just write this over here because we need to work out the center of rotation. And what I would recommend to do in the exam is put tracing paper on your shape A, draw around it, and then try different points to rotate around until you get to the correct answer. Okay, so there are a couple of different ways you can approach this instead. I will try and keep this as as straightforward as possible. What I would do here is I take this particular point of the shape. You can do this with any point, but I'm going to take this one. And essentially you try different points here until you get the gradients equal to -1. Now that sounds quite confusing. I'm going to try this point here. So this is 0, -1. If I join these up, okay, you'll see you get this line here. If I take the equivalent point on the other shape, so let's take this in blue instead, and do the same thing. So I'm going to join these up. I'll try and make this as accurate as I can, like so. Hopefully you can see here that there is a 90-degree angle in between, and you can check this with your protractor as well. So what you're looking for is a point between corresponding points of the shape that meet at a right angle. And actually you can check this with this point here as well. That also makes a right angle, and this here also makes a right angle too. So my rotation point here is going to be 0, -1. And you can do this without tracing paper by doing this kind of check, choosing different points, and then seeing when you get a right angle. But tracing paper is really the easiest way to go. Now we've got a different kind of question where we want to look at triangle A to C. So let me just rub this out so we can talk about this. This is easier to do without tracing paper. So first of all, we're going from a bigger shape to a smaller shape. So this has to be an enlargement. We still use the word enlargement, even though we're going from a bigger shape to a smaller shape. But our scale factor, instead of being a bigger number, because it's getting bigger, it's going to be a fraction because we're getting smaller. Now notice this is here 3. Here this is 1. What do you do to 3 to get to 1? Well, we divide by 3, and that's the same as timesing by 1/3. So our scale factor is going to be 1/3. Remember, we're going from A to C here, not C to A, which is why this is 1/3 and not 3 instead. And now we need to work out where the enlargement point is. So where are we enlarging from? Now the way we can do this, you need a ruler for this, is we connect up corresponding points and then draw the line all the way through, the so-called ray method. So if I join this up, okay, I'm going to get a line that looks like this. And what we do is we just continue this line all the way through. So keep our ruler nice and straight, and we go all the way through. Let me just keep going all the way through, as straight as we can. If you've got a ruler, this makes your life a lot easier. We take another corresponding point, so this one here, and we do the same process. So we connect this up with here, with a ruler. That's a little bit on the bendy side. And then we continue that line all the way through. And you'll notice we've already crossed the point 66 here. But in the exam, I would check that this is the case by doing my very last point of the shape and doing exactly the same process. So I draw my line. It's pretty straight, it's not too bad, and I keep going all the way through. And you see this confirms that we actually do cross for all three of these particular lines the center of enlargement point 66. So that's going to be our enlargement point. I'm going to write COE for center of enlargement, and then I pop down 6, 6 like so. Okay, and the last part of this question is we need to draw the image of triangle A. So always using triangle A in this case, after a translation by the vector 210. And the way we do this is we take our vector. Let's think about what this means. So the top number tells us if we move left or right, positive for right, negative for left. So we're going to go 2 to the right. And then the bottom number here, this is a 10, and that tells us if we go up or down. So in this case, the positive direction is upwards, so we're going to go 10 up. So we're going to take this triangle here, triangle A, and we're going to go 2 to the right and 10 up. So let's count here very carefully. We're going to take 1 point on our triangle. So we're going to go 1, 2, like so. And then notice our scale here is exactly the same. So we're going to go 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to move to the point here, minus 4, 7. Now at this point you could do the same process with this point down here and this point down here. But because we know the shape is going to stay the same, we can use this as a reference point. So notice from here we go 1, 2, 3, 4, 5, 6. So here we're going to go 1, 2, 3, 4, 5, 6, down to minus 4, 1. Then we go 3 across, what we mentioned earlier. So 1, 2, 3. And then we're going to draw the line in like so. Okay, and I'm going to use a dash to represent to the examiner that that is my image and that answers question B. Okay, so you can check, the questions we've just done there. So some of these are getting a bit more complicated. So feel free to have a look through, look at the mark schemes, and you can see where I've picked up all the marks for the questions you've just seen. Okay, and on to question 11. So we need to simplify the following expression. So 4ab to the power of 5 all to the power of 4. And the key thing to remember here is apply that power of 4 to each part individually. So we're going to do 4 to the power of 4 on its own, a to the power of 4, which is nice because we don't have to do anything, and then b to the power of 5 all to the power of 4. So we need to work all these things out separately. Now you've got a calculator to work out 4 to the power of 4. Remember this means the same as 4 times 4 times 4 times 4. That will be equal to 256. A to the power of 4 stays the same. Nothing happens here. And remember, b to the power of 5 all to the power of 4. So whenever you have brackets with indices, with these small numbers, you multiply them together. So 5 times 4 is equal to 20, leading us then to our answer, like so. And the next question here, so we need to find the value of p. So we have 2p to the power of a third equals 6. So we treat this like a normal equation. So what I mean by that is, right, we have 2p to the power of a third. We want to get the p on its own. So what's the opposite of timesing by 2? Well, let's start with dividing by 2 on both sides. So this cancels, and we're left with p to the power of a third is equal to 6 divided by 2 is equal to 3. Now at this point you may recognize that 1/3 is the same as a cube root, But another way we can think of this, I'll write it just above here so you can see this a little bit easier, is we think about, right, how do we get rid of the third? And the way we can do that is by cubing. Now let's just think why this works. Well, what's 1/3 times 3? Well, that's equal to 1. So we get p to the power of 1. 1/3 times 3 is equal to 1. But remember, we have to cube the other side. So we have to do 3 cubed. And 3 cubed is 3 times 3 times 3. And that gives us our answer of 27 for our 1 mark. Now question C, we have 81 squared divided by 3 to the power of t is equal to 9. And we need to find the value of t. Now I did this kind of question with my year 12s quite recently. And the key strategy to remember here is to get the same base of number. Okay, so get the same base. Now, what do I mean by this? So we want to get every number and we want to write it as 3 to the power of something. Now luckily these numbers are written in such a way where we can do that. So I'm going to write out the equation 81 squared divided by 3 to the power of t is equal to 9. So I'm going to write each of these as a power of 3. Now 9 is the same as 3 squared. That's very helpful. 3 to the power of t is exactly what we want so far. And now we think about 81, and we go, well, 9 squared is equal to 81. That's true. And 3 squared is equal to 9. So that means then, actually, 3 to the power of 4 is equal to 81. And you can check this through in your mind. So 3 times 3 is 9. 9 times 3 is 27. 27 times 3 is equal to 81. So I'm going to replace the 81 with 3 to the power of 4. Now at this point, we use the same rule that we did up here. So when you have brackets with indices, we multiply those together. So we get 3 to the power of 8 divided by 3 to the power of t is equal to 3 to the power of 2. And I think at this point we can see, well, what does t have to be to make this true? And when you're dividing, it's the same as minusing. So 8 minus something is equal to 2. Well, our something must be equal to 6. Okay, you can write this again in a slightly different way if this helps. 3 to the power of 8 minus t is equal to 2. 3 squared. Therefore, 8 minus t is equal to 2. Okay, nice question. We do quite a lot of this on the A-level course as well. So make sure this is nice and firmly secure. Excuse me. Question 12. So the profit a company makes decreases, that's important to be aware of, exponentially at a rate of 0.9% per year. And in 2014, the profit was $9,500. Calculate the profit in 2019. So we need to think about how we're going to structure this. So notice we've got this decreasing exponentially. So we need to find out the multiplier. So we take 100%. We're going to minus the 0.9%. That's what it's going down with each time. And this gives us 99.1%. And we can write this as a decimal. We can write this as 0.991, okay, just by dividing by 100. This is what we call our multiplier, which is very helpful. Now let's work out how to work out profit in 2019. So we're going to put profit 2019. It's essentially a geometric series. So we're going to take 9,500. That's going to be our starting point in 2019. We take our multiplier, so 0.991. And if we multiply anything less than 1, it's going to go downwards, so that's good. Now we need to work out what year we want that in. Well, when this is 0, then that's our 2014. So 2015 is going to be 1, 16, 17, 18, 19. So we're going to want to use the number 5 here. Okay, so we're going to pop this into our calculator and see what we get. Okay, and we get our answer of 9,080.6 0.126, which we're going to round to the nearest cent. So let's go back and pop it in. Okay, and that's our final answer. Just make sure that you do put any money calculations with dollars and cents. So make sure you do money calculations in the correct way. Okay, question 13. So on our map, a lake has an area of 32 square centimeters. The scale is 1 to 24,000. We actually want the actual area of that lake in square kilometers. So under this. So I'm underlining the key information. Right, one thing to notice here, we're looking for an area, not a length. So our scale factors are going to change quite dramatically. So let's give you an example. If I take a square of a 3 by 3 square, we all know the area of that is equal to 9 square centimeters. Now if I times each of these sides by 3, we get 9. So imagine I do a larger square. That's not very much of a square, it's a bit of a rectangle, but stay with it, no worries. So 9 times 9 is equal to 81 square centimeters. Notice my length scale factor here is equal to 3. So if I was looking for a length here, okay, I could just use my normal scale factor here, 24,000. But because we're looking for an area, you see square centimeters, you'll notice to go from 9 to 81, we actually can't just times by 3, but we need to times by 3 squared, which is equal to 9. So consider that as we talk through this problem. So the way we go about doing this, so I'll break it down in stages. First of all, we need to multiply the 32, not by 24,000, because the length scale factor, but we want to multiply by the area scale factor. So that's going to be 24,000 squared. So let's just work that out on our calculator. Okay, so we get our answer. It's a very, very big number. So it's 18432 and 6 zeros. Okay, now that gives us the answer in square centimeters. So that's what the answer is so far. But we need to get this in square kilometers. So we're going to do this in 2 stages. So I'm going to take my number, 18432, 1, 2, 3, 4, 5, 6. You don't have to write this in the exam. First of all, I'm going to convert that into square meters using the same logic here. So there's 100 centimeters in a meter, but we're going to square that because we're working with square units. So if we divide that, we are actually going to lose 4 of our zeros. So you can check this on the calculator. So we get 18432, and we're going to get how many extra zeros? Just 2 zeros like that. And that's going to be in square meters. But we don't want square meters, we want square kilometers. So we take our answer 1843200, okay, which is 1,843,200 square meters. And now we're going to divide by 1,000 squared. Now why are we doing that? Because 1,000 meters is in a kilometer. We're going to square it because we're using square units. And if we do that, we'll get our answer of 1.8432, which is our answer in the unit that we want. So it's a nice question. It's a mixture of working with map scales, but also realizing we're working with square units. So when we're times and dividing, we need to make sure we are squaring as well. Okay, you can check your answers, so check what we've done so far. We're up to lucky number 13, but we'll be continuing on shortly and doing some of the harder questions from the paper. And on to question 14. Okay, sticking with me, let's keep going through these questions. So, y is directly proportional to the square root of x minus 3, so slightly non-standard. And then we've got some initial conditions that will help us work out what y is. So we're going to do this in a very standard approach. So first of all, we write our proportionality statement. So y is proportional to that weird fish symbol you might have seen, and we're going to be to the square root of x minus 3. So that means if we write this as an equation, y is equal to some constant k times the square root of x minus 3. That's a kind of basic equation we're going to work with. Now we want to work out what k is, so we use our first initial conditions. When x is equal to 28, y is equal to 20. So we go 20 is equal to k, square root of 28 minus 3. And it's just working through the algebra here. So 28 minus 3 is equal to 25. The square root of 25 is equal to 5. And if 5k is equal to 20, then k is equal to 4. So this is the key information that we needed. So the equation we're going to use for the rest of the question is this one, but instead of a k, we now know what k is. So we get y equals 4, the square root of x minus 3. And this now helps us work out what y is when x is equal to 39. So we go y equals 4 square root 39 minus 3. Again, remember your BIDMAS, so we need to work out the square root first, then we multiply by 4. So 4 lots of the square root of 39 minus 3 is 36. The square root of 36 is equal to 6. And now we do our multiplying. 6 times 4, look at that, all perfectly put on the page, is equal to 24. And we get there. This is a very common kind of question. If I remember my predictions correctly, it's in the often category, so make sure you can do this kind of standard 3-mark question. Question 5 is also a reasonably often topic, which is making subjects or formulae. This time this is quite a tricky one because it's out of 4 marks. We want to make H the subject. So I'm going to go through our standard strategy, which is first of all, we're going to expand out any brackets we have. So 2mh is equal to, we'll use the hook. So 1 times g is g, g times minus h is minus gh. And the key strategy, because we want h the subject, we want everything with h on one side of the equation, everything else on the other. So if I follow that strategy, I want to get this h term on the right hand side. So what's the opposite of minusing gh, or adding gh on both sides? Thinking y at this point, which is fine, we will go through this very carefully, and we get this expression here. Notice these two things cancel. Now this is the step that really goes from sort of standard BA grade mathematician to A star, and this is we're going to put this into a single bracket. Notice these two things have h in common. So I'm going to bring h out here, I'm going to make a single bracket, and then we work backwards. So what do we multiply h by to get 2mh? Well, 2m. What do I multiply h by to get gh? Well, just g. And the reason we've done that, we've now reduced the number of terms with h from 2 to 1, and now we can just divide by the bracket. So we're going to divide by 2m plus g on both sides, like so. Again, this has the lovely effect of cancelling, so we then get h is equal to g over 2m plus g. And that is our final answer. So we're going to pop that over here. Notice you get 4 marks for not too much working. It's more understanding the strategy, knowing what you need to do for this kind of question, and you can see you can do this in best part of 2 minutes. Question 16, we're going to work out the gradient of line L, so up on the board. Now whenever you want to work out a gradient from a diagram, try and find where it crosses a whole number. So taking that into account, notice it crosses here, and it crosses here at whole numbers. So remember to work out the gradient, we're looking at the change in y over the change in x. So how much are we going down in y? Well, we're going down minus 3. And how much are we going across here? Well, let's count, we go across 4. So if I use my gradient formula, which is the change in y, using that triangle for change, over the change in x, let's have a look. Well, we're going 3 down and 4 across. So we get minus 3 at the top, the change in y, over the change in x, which is 4. Generally, we don't write fractions like this. We're just going to write it as minus 3/4. Now we've worked out the gradient, working out the equation of the line is very straightforward. Notice The c part of y equals mx plus c is our y-intercept, so where it crosses the y-axis. So in this diagram, it crosses the y-axis at 2. We already know the gradient, so all we need to do is replace the m with minus 3/4 and the c with 2. So we get y equals minus 3/4 x, and then the c is equal to 2, because that's where it crosses the y-axis. I'm quite surprised they give you 2 marks for that, but you still need the appreciation of what you worked out in part A. Now, I'm going to write that down here, so y equals minus 3/4 x plus 2, because I'm going to need that for the next part of the question. So now we need to work out the equation of the line that's perpendicular, it's a very important word, at a right angle, to line L and passes through the point 12 minus 7. So, our original gradient, our original m, was equal to minus 3/4, and we want to find out the perpendicular gradient. We're going to call that perp m, not a perpetrator, but perpendicular. And the way we do that is we flip the fraction. So we're going to flip our fraction, 4/3, and then change the sign. So we're going to change it to a positive. So you ever see perpendicular in a y equals mx plus c question, you take the original gradient, flip it, and then change to a plus. So we know the general equation of our straight line is y equals 4/3 x plus c, and now we need to work out the y-intercept. Well, we've got some extra information here. That's very handy, so we're going to substitute that in. So when x is equal to 12, y is equal to minus 7. So we pop that in. Minus 7 is equal to 4/3 multiplied by 12. That's handy. Plus c, because things are going to cancel, which is always good. So notice we can cancel here. So 3 goes into 3 once. 3 goes into 12 4 times. So we get minus 7 equals, well, 4 times 4 is 16, plus c. And so if we want to work out what c is, we want to get it on its own. What's the opposite of plus 16? Minus 16. Standard equation stuff. And please don't make a mistake here. So we get c on the right-hand side. Minus 7 minus 16 is equal to minus 23. Just be very careful with that. So we combine it all together. So we have our 4/3 x for the gradient, and then minus 23 for our y-intercept. Again, when you go through these questions, by all means, pause the video, really try and take in what I've been talking about, and then play it again. Don't feel you have to go at the same pace as this video. Okay, mark scheme on the board, so for questions 14 to 16. So check through what I've done, see if that makes sense to you. And again, if you're not so sure, go back through the paper and have a go at the question yourself, and then watch the video afterwards. Okay, and we've got 17 to 20 to go, so let's keep on. So a bag contains 3 blue buttons, 8 white buttons, and 5 red buttons. 2 buttons are picked at random from the bag without replacement, so the probability is going to change as we go through the problem, and work out that the 2 buttons are over both red or both white. Now, I do recommend a tree diagram to do this, but I do not recommend to fill everything in. So let's put this together. So here's my initial tree diagram that I'm going to draw, and we're going to have blue there, we're going to have white here, and we're going to have red here. And then the second choice will have the same options. So we'll have blue here, white here, red here, and the same for the other options as well. Now this looks quite bewildering at first, a bit crazy, like we have to work out everything, but we just need to think which situations we actually want to work out. So let's go through this. The first part is, well, how many buttons do we have in total? Well, we've got 8, 11, 16 buttons. So the probability of getting a blue button is 3 out of 16. Now I'm still going to write this as a unsimplified fraction, so 8 out of 16 here, and then 5 out of 16 there. And now we just need to consider the situations we want, which are two buttons either both red or both white. So the only solutions I need to find here is this one and this one here. Okay, so I'm identifying what I need. Now, to work out this one here, well, if I go down the blue route, I've already chosen a blue one. And I just realized I don't want to choose a blue one. I want to choose a red one and a white one. So we need to go down here and here. See, as you go through the question, you should check these things, and if it's not correct, then just change it as you go through. So let's go through the situations again. So we want both red or both white. Well, if we've got both white, let's start with white. So we've got 8 out of 16. Now we've chosen the white, so that's going to get reduced down to 7. And then how many buttons do we have now? Well, we're down to 15. So we start with 8 out of 16. We've chosen a white button, we don't put it back. There are 15 buttons left, and then we've only got 7 white in there. Now we go right back to the start. So we have 5 out of 16 that are red, and then we go choose a red button. So we only have 4 red buttons left, and we have 15 in total. So we need to work out these probabilities. So we work out the probability of white, white. Remember, we multiply along the branches, so we do 8 out of 16 times 7 out of 50, which I'm going to leave for the moment. We do the probability of, not blue, I really want to find out blue. It's probably because it's at the top. It's interesting psychologically, yeah? So the probability of red, red, which is what we want, is equal to 5 out of 16 times 4 out of 50, like so. So we get 56 on the top here. Now 16 times 15, I think I'll just use my quick calculator I've got here. That's going to be equal to 240. And notice we haven't simplified any fractions before for a very specific purpose. 5 times 4 is 20. 16 times 15 is equal to 240. And we want the probability of white, white, or red, red. So we're going to add those fractions together. So if we add those fractions together, we've got the same bottom number. So we get 76 out of 240. Now we can actually simplify that down. So we can divide top and bottom here by 4. And then we get our simplified answer of 60 on the bottom. Again, you can use your calculator for this. 76 divided by 4 is equal to 19. And we have our answer. So the key thing is, don't do what I did at the start. Make sure you're doing the red and white options and don't include the blue. Make sure you know the options that you want, and then from there you can actually work out the probabilities you need. Question 18, a typical vector algebra question, particularly towards the end of the paper. S is a point on PQ such that PS to SQ is in the ratio of 4 to 5. Now before I even start, I like to write down the fractions for this. So P to S is the left hand side, so that's going to be 4/9 of the line. And let me change my colour. SQ, well, that's going to be 5/9 of the line, because that's going to be important a bit later on. Now, we want to work out the vector OS. So we want to go from O to S, going this direction. So the vector OS, if I break it down into two parts, is going from O to P, which we already know, that's A, that's helpful, plus PS, which is going to be more difficult to work out. Now we can't work out PS directly, but we can work out P to Q. Now the way we can work out P to Q, I'm going to pop this over here, is we go from P to O, we're going to go backwards to the arrow, and then we add on OQ. Remember, as long as you can go any direction, it's still the same vector. So P to O is not going to be positive A because of the arrow, but minus A. Notice put your squiggles under your vectors. And then P to O and then O to Q is just going to be B. Like so. Now that's the vector PQ. So the entire vector, if I just draw an arrow here, is equal to minus A plus B. But for PS, we don't want the entire line. We want 4/9 of it. So we can actually work this out now. So OP is equal to A. PS is 4/9 of PQ, the one we just worked out, which is minus A plus B. At this point, it's just a case of a bit of simplifying. So if you multiply this out, we get A plus, well, we're going to use the hook. So we're going to put a minus there. There we are. So minus A times 4/9 is minus 4/9 A. And then plus 4/9 B. And if we work this out, well, A is the same as 9/9. So 9 minus 4 is 5. So this is going to become 5/9 A, making sure you put the squiggles, plus 4/9 B. And we're going to write that down in the answer section, like so. And that makes kind of sense as well. If you think where S is, it's going to be a positive part of A and a positive part of B as well. So use a common sense check to think where is the vector OS, where it's going to be a mixture of A and B, both in the positive direction. Question 19, a bit of trig sketching, so this is always good fun. Sketch the graph of y equals tan x between 0 and 360. So you simply need to know these off by heart. Tan is one that often gets forgotten, so do make sure you revise. So the graph looks like so. I'll do my best with the tablet. So essentially we go up like this, and we go off to infinity. Now you don't want to curve back on yourself, so I'm going to try and do this as best I can. Then we're going to come back from minus infinity here, and then go to 180, so this joins up at 0, and then we're going to repeat the same graph. Notice this graph repeats every 180 degrees, which is going to be useful a bit later on. I would also, in the exam, mark in the asymptote. So what I mean by asymptote is, this is the line that it kind of just it doesn't quite touch, but gets very, very close to. So I'm going to mark those in as well to show to the examiner those lines get closer and closer and closer, but don't actually touch. Try and make sure it doesn't curve away. That's really important. I think that does slightly, but just do your best. And now we're going to use this to solve the equation. So let's go through this now. We've got 5 tan x equals 1. So like most equations, we want to get the x or tan x on its own. So what's the opposite of timesing by 5? Well, we're going to divide by 5 on both sides. This cancels, and we get tan x is equal to 1/5. And essentially what we're trying to do here, if I mark on, say, 0.2, I'm not entirely sure where it is, we'll call it there. What we want to do, this is what we're doing graphically, is if I draw a horizontal line going all the way across, we are looking for the cases where they cross, and notice they cross twice. Now our calculator is clever enough to work out one of it for us. So if we take tan x equals 1/5, I'm sure you've learnt this already, that to work out x we do the tan inverse of 1/5. Make sure your calculator is set up in degrees and not radians. So if we do tan inverse of 1 divided by 5, your calculator is clever enough to give you one answer, which to 3 significant figures is 11.3 degrees. However, as you can see, there are 2 boxes here. This is not the only answer. We found out this answer here of 11.3, but we also want to find this answer as well. Now you'll notice I said earlier that this graph repeats every 180 degrees. So our second answer, all we need to do is take our 11.3 ... and then just add on 180. Okay, this only works for tan, doesn't work necessarily for sine and cos. So if we take the answer we just did, which was 11.309999, add on 180, and we then get our answer. Remember, to 3 significant figures is going to be 191 degrees. So we pop that in there as well. So many people find it okay to find one answer and solve the equation, but it's the other answer to find that is tricky. And I've used our diagram to help visualize exactly where that is. Okay, and the very last question, so question 20, is interesting choice for a last question, no differentiation, but the lower and upper bound. So A distance between two towns is 600 kilometers, correct to the nearest 10 kilometers. That means that the answer can vary between 595 and 605. Notice if it's 595, it rounds upwards. If it's like 604.999999, it'd round down to 600. A car takes 8 hours 40 minutes, correct to the nearest 10 minutes, to travel this distance. So the time can vary between 8 hours and 35 minutes and 8 hours and 45 minutes. And we want to find the lower bound for the average speed of the car. Now remember, speed is equal to distance divided by time. So make sure we remember that formula. And we want to find the lower bounds, yeah? So the low speed. We'll put L speed for our reminder. And to work out the lowest speed, we want the lowest distance, smallest distance, over the highest time taken. Now, if you're not sure about the logic of that, you can try out different numbers and see which one gives you the lowest. But to get the lowest bound speed, you need to find the lowest distance on the top over the highest amount of time. Now, the lowest distance was 595. That was our lower bound here. And the upper bound for the highest time was 8 hours and 45 minutes. Now, we have to be a little bit careful because we want this out of in hours, not minutes. So we need to convert this to hours only. Notice 45 minutes is 3/4 of an hour. So we can write this as 8.75 hours. Okay. So we have to make sure this is in the right units. So then we go 8.75 like so. And now we just pop this into our calculator to give us our answer. So 595 divided by 8.75 gives us exactly 68. It's probably a good sign if we're getting a whole number. And that is going to be our lowest bound for the average speed of the car. If you wanted the highest speed, then you'd have the maximum distance over the minimum time taken. Okay, and that's the final mark scheme I'm going to show up on the board so you can check what we've done as well. Okay, make sure those sketches are a bit better than mine, but I'm doing my best with this lovely pencil here as well. And the last part here as well for the answer of 68. And probably what you've been waiting for at the end, okay, what are the grey boundaries for this particular paper? So we looked at component 2.1, so it's out of 70 this particular paper. You only need 46 marks here. Out of 70 to get an A, you only need 50%, so 35 out of 70 to get a B, and you can see only 25 marks to get a C as well. So this also gives you an idea of what grade you're working at by going through this walkthrough video. So I hope you enjoyed a 0580 and 0980 maths walkthrough. If you're liking these videos, again, please do like and subscribe and comment down below what you think in case I can improve the format in any way. I'm happy to hear your comments. I do try and reply to everybody that comments down below. All right, I'll see you on next video and bye-bye for now.